So first we can talk about just random sampling. This is a process of using chance to select individuals from a population to be included in the sample. So with a random sample, we select members of the population in a way so that each individual member has an equal chance of being selected. A simple random sample is a little bit more complicated because for this we still want to have each individual member having an equal chance of being selected, but we also have to do this in a way so that every possible sample of size n has the same chance of being chosen. So whatever size we want our sample to be, say we want it to be size 10, we have to do this so that every possible sample of size 10 has the same chance of being chosen. Here's an example. Suppose we need to select a simple random sample of size 30 from the children who attend a particular elementary school, which has grades K through 5. To get a simple random sample, basically there can't be any organized method of selection. It has to be completely random. In this example, we could use a random number generator to select 30 names from the list of all students at the school, or another way to get a simple random sample is to put all the students' names into a box and draw out 30 names. Stratified sampling means that we subdivide our population into at least 2 different subgroups, usually more, that share the same characteristics, and then we draw a sample from each subgroup. For example, we might divide into women and men and then select randomly a certain number from the group of women and a certain number from the group of men. Another example, if we go back to our elementary school, to get a stratified sample of size 30, we could divide the students into groups by grade, so 5th grade, 4th grade, and so on down to kindergarten, and then randomly select 5 students from each grade. And this means that we have a list of the population, and we just go through and select every kth one. For example, in this picture, we'd be selecting every 3rd individual from the population. If we were going to do this in our elementary school example, to get a systematic sample of size 30 from a population of 400 children, we need to select every 13th name on the list of children. We get 13 because if we divide our total population 400, that gives us 13.3. So we'd round that down to 13. Now our starting point would need to be some randomly selected name on the list, somewhere between number 1 and number 13 on the list. So we'd select our starting point. That would be our first individual for our sample, and then after that we'd take every 13th name on the list. Cluster samples are easy to confuse with stratified samples, because here we also divide the population into groups. We call these clusters. The difference between this and a stratified sample is that once we divide into groups, then we randomly select some of those groups and we take all of the members of those groups to be in our sample. Here's an example. If we had a state divided up into precincts and we wanted a cluster sample of the voters, then we would randomly select, in this case, 3 of the precincts, and we'd interview all of the voters in those 3 precincts. If we were doing a stratified sample, we would take a certain number of voters from each different precinct. That would be the difference. Here's another example. Back to our elementary school. If we go in at lunchtime and divide the students into groups by which lunch table they're at, assuming each table seats 10 children, then we could randomly select 3 of those tables and choose all of the students from those 3 tables. That would get us a sample of size 30. It would be a cluster sample because we're randomly selecting the groups and then selecting all of the students from those groups. Convenience sampling means that we just use results that are easy to get. And you actually see this a lot. This would be things like the newspaper reporter who stands on the corner and interviews the first 10 people that walk by. Now, convenience sampling is not a statistically valid sampling method. If you see this, sometimes the results are interesting, but they're not statistically valid. Here's a summary of our sampling methods. We have simple random, stratified, systematic, cluster, and convenience. If you're trying to identify whether something is a simple random sample, if the sampling method gives you a random sample and you can't identify it as systematic, convenience, stratified, or cluster, then it's simple random sampling. Again, simple random sampling means there's basically no organization to how the sample is selected.